Wait, hold on. That line under the city wasn't supposed to be there. The scan was meant to confirm solid ground, boring ground, the kind you expect under a place like downtown Boston or the older parts of New York. But instead, right beneath Cusco, the image broke into gaps, long ones, clean ones, running under an ancient city the way tunnels run under Manhattan, except no one ever admitted these existed. Stay with me on this. Seriously, if you re the kind of person who likes knowing about things before they re-cleaned up and repackaged, this is one of those moments. You'll want to keep an eye on what comes next here, because this didn't surface the way discoveries usually do. Cusco looks solid from above. Heavy stone, narrow streets. Walls that lock together so tightly they've survived earthquakes that flattened entire modern neighborhoods in places like San Francisco. You walk there and you feel safe, anchored. That's why the room went quiet when the data finished rendering. The ground wasn't behaving like ground anymore. This wasn't a treasure hunt. No one was chasing legends. The scans were routine, the same kind of ground-penetrating radar and acoustic testing used under American highways, subway expansions, older bridges. Engineers do this all the time. It's boring work. Until the signal starts passing through places where it should have slammed into solid earth. At first, it showed up as noise, a faint inconsistency, the kind of thing you blame on calibration. Someone even joked it looked like a subway line, which made no sense because Cusco doesn't have one. Then the line didn't go away. It stretched, it bent, it intersected with other gaps, empty stretches, not caves, not loose soil, structured absence. And that's the phrase that started making people uncomfortable. Because engineers don't like absence that behaves like design. Absence isn't supposed to have edges. This did. Here's where the comparison matters. Imagine running scans under downtown Chicago and finding long, continuous hollow spaces that don't match any recorded infrastructure. No blueprints, no permits, no historical mention. Just clean voids cutting beneath streets that millions of people walk every day. That's the feeling in the room. They ran the scans again, different angles, different equipment, same result. The gaps weren't random. They followed paths. They curved gently like someone had planned for stress and load the way modern tunnel systems do. Except these weren't modern, and they weren't shallow. What made it worse was how little the gaps cared about the city above them. Modern streets crossed right over them. Colonial buildings sat on top of them. In some places, even ancient stone walls lined up with them, like the builders above already knew exactly where the empty space was. Sit with that for a second. Because Cusco wasn't supposed to be built over anything like this. The story we're taught is simple. Inca builders worked on the surface, roads, terraces, temples, no deep infrastructure, no underground networks. That explanation works fine until the ground itself starts disagreeing. Someone suggested natural formations. That idea lasted about as long as it took to map the geometry. Natural voids don't run straight for hundreds of feet. They don't intersect at consistent angles. They don't mirror the kind of planning you see under cities like Washington, D.C. And here's the part that quietly changed the tone of the conversation. When the team overlaid the scans with known ancient stonework, some of the alignments matched too closely to ignore. Walls placed centuries ago were sitting directly above empty space, as if weight, balance, and void had all been considered together. That's not coincidence. That's coordination. At this point, the question stopped being whether something was there. It was there. The data made that unavoidable. The question became when it was made, and why it was never meant to be seen. Because if this network exists beneath Cusco, it wasn't hidden by accident. It was hidden by time, by silence, and by the assumption that ancient cities were simpler than ours. And that assumption is about to become a problem. What happened next is where the explanations started falling apart. Once the presence of these voids couldn't be dismissed anymore, the team did what engineers always do when something doesn't fit. They tried to shrink it, shorten it, isolate it, make it small enough to control mentally. But every new pass did the opposite. The network grew, new branches appeared, some ran straight, others curved slowly, the way modern transit planners bend tunnels to manage pressure and terrain. That's when someone finally said it out loud. This doesn't look accidental, because here's the thing Americans understand instinctively. You don't get underground systems by chance. You get them when someone plans for movement, access, flow. Subways under New York didn't appear because the ground cracked. They were designed. Sewers under Chicago weren't guesses. They were engineered responses to scale. So when scans show something similar under an ancient city, the comparison isn't poetic. It's practical. The depth was wrong too. These weren't shallow service channels. Some sections dropped deeper than modern basements, deeper than utility lines, closer to the depths you'd expect for something meant to last. That raised a quiet but serious concern, because deeper construction means more effort, more planning, more reason. If this was infrastructure, it wasn't casual. At this stage, historical explanations were pulled in to calm things down. Maybe later cultures reused older spaces, maybe colonial tunnels, maybe undocumented storage. Those ideas sounded reasonable until the dates refused to cooperate. Sediment analysis around the void edges showed age consistency with pre-colonial layers. No signs of later excavation, no tool marks from metal implements, no collapse patterns you'd expect if someone had dug after the fact. The earth around the spaces had settled naturally over a very long time. In other words, these spaces were old, older than the streets above them, older than the buildings people point cameras at today. Now imagine being told there's something running under a city like Philadelphia, older than the city itself, with no records, no mentions, no warning. That's the mental shift that started happening in the room. And then came the alignment problem. When the underground paths were mapped against surface landmarks, the overlaps weren't random. Certain corridors ran beneath keystone structures, plazas, and junctions, not directly under the center but offset. Like someone understood load distribution and intentionally avoided placing weight directly above empty space. That detail matters, because it means the builders weren't guessing. They weren't hoping the ground would hold. They knew where it wouldn't. This is where I started feeling uneasy with the standard narrative. We're told ancient builders were masters of stone but limited in scope, that they worked with what they could see. That underground complexity came later with industrial tools. But this didn't look limited. It looked cautious, thought through, conservative in the way experienced engineers are conservative. And then someone asked the question no one wanted to answer yet. If these tunnels were meant for people, where are the entrances? Because so far none had been found. No obvious access points, no stairways, no ramps, no openings leading down from known structures. The network appeared sealed, continuous, and inaccessible from the modern surface. That rules out casual use, it rules out storage, it rules out everyday traffic, which leaves a narrower set of possibilities. Before jumping to those, the team tried one more angle. They checked vibration data, microseismic responses, the kind of analysis used in the US to assess underground stability near fault lines and subways. The results showed the voids interacted with surrounding stone in a way that suggested intentional reinforcement. Certain sections were buffered, others were isolated. That's when the comparison shifted from subway to system, because systems aren't just spaces, they're relationships between spaces. And once you see that, the idea that this was just some forgotten construction phase starts to feel like denial. At this point, the conversation stopped being technical and started becoming careful. Not loud, not dramatic. Careful. The kind of careful you hear in US infrastructure meetings when someone realizes a bridge problem isn't cosmetic. When the room understands that whatever they say next changes what comes after, because here's what wasn't lining up anymore. If this underground network was meant to move people, it failed at the one thing movement systems require: access. No entrances means no traffic, no wear patterns, no debris. No signs of use the way you'd expect in tunnels under places like New York or London. But if it wasn't meant for movement, then calling it tunnels might already be the wrong word. The radar signatures showed sections widening and narrowing, not randomly but rhythmically, like zones, compartments, the kind of layout you see in facilities designed for function, not travel. That distinction matters more than it sounds. In the US, When engineers look at underground layouts, they don't just ask what it is. They ask what problem it solves. Flood control, transport, storage, stability. Every underground structure answers a need. So what need does a sealed, inaccessible network beneath an ancient city answer? Before anyone could chase that thought too far, another inconsistency surfaced. The voids weren't uniform in height. Some sections were tall enough to stand in, others compressed tightly like channels. That suggests different purposes within the same system, different tolerances, different priorities. At this point, someone brought up oral history, not legends, not myths, local accounts that mention passages beneath the city, usually dismissed because no entrances were ever found. Those stories had always been treated the way Americans treat urban legends about secret tunnels under old courthouses or abandoned subway lines. Entertaining, unverifiable, safe to ignore. Except now the ground was verifying something. Here's where I want you to pause with me for a moment, because this is where most viewers decide whether they're going to stay or leave. If you lived in a city like Seattle or Denver and scans suddenly showed sealed underground structures running beneath historic districts with no modern access points and no records, would you assume coincidence or intent? Don't answer yet. Just notice which way your mind leans, because the deeper they mapped, the clearer the pattern became. This network wasn't sprawling endlessly. It was bounded, deliberately limited. Like someone drew lines and said, only this much. That's not how accidental features behave. Another detail quietly changed the weight of the discovery. The underground paths avoided certain geological weaknesses, fault lines, water-prone zones, areas modern engineers would also avoid if they had the choice. That implies knowledge, not guesswork, and that's where the timeline starts pressing in. To know where not to build, you need observation over time. You need experience with collapse, flooding, stress, or you need knowledge passed down deliberately. Either way, it suggests planning depth we don't usually associate with surface-focused societies. The silence in written records now felt louder than before. No inscriptions describing construction, no celebrations of achievement, nothing carved into stone saying, "We built this." In American terms, it would be like discovering a massive underground project beneath DC, with no congressional record, no budget trail, no photographs, just results. That absence isn't neutral, it's a choice. At this stage, one explanation kept coming up because it was comforting. That whatever this was, it had a ceremonial or symbolic role. Something spiritual, something abstract. That explanation allows you to stop asking practical questions. But the data didn't behave symbolically, it behaved operationally, and once you accept that, the idea that this network was never meant to be entered starts to feel less strange than the idea that it was. Because systems don't always exist for people. Sometimes they exist to support something else. And that realization is where the room started to feel smaller. And once you reach that realization, the discovery stops feeling distant in time and starts feeling uncomfortably close. Because planning for failure is not a cultural quirk, it's a mindset. And mindsets don't disappear unless the conditions that created them disappear too. In the US, we don't build hurricane shelters in places that have never seen a storm. We don't reinforce bridges unless we've learned what happens when they fail. Preparation is always downstream of experience. That's why the underground system beneath Cusco feels like a memory made of stone. Not a story, not a myth, a response. No overbuilding, no sprawling maze for the sake of grandeur. Everything is measured, limited, enough to do the job and no more. That kind of restraint usually comes after trial and error, when builders know exactly what's required and exactly what isn't. Modern American infrastructure looks like that too once it matures. Early systems are messy, later ones are precise. Cusco's underground network doesn't look like an experiment. It looks like a final draft, and that should give anyone pause, because final drafts imply previous versions, attempts that didn't survive, solutions that weren't good enough. Those earlier versions are missing from the archaeological record, which brings us to a quiet but important point. The absence of evidence here isn't neutral. It's selective. We see the solution, but not the failure that led to it. That asymmetry is rare. Usually ruins tell us what went wrong. Here they tell us what went right. That inversion is what keeps drawing comparisons to contingency planning in modern cities. Backup systems don't advertise the disasters they were built for. They exist so those disasters never become stories. If this underground network was built to prevent something, then its success would erase the very evidence we'd need to understand it. And that's a deeply uncomfortable loop, because it means the better the system worked, the less history it left behind. At this stage, the discovery under Cusco stops being a puzzle to solve and starts being a mirror. It reflects a version of human behavior we like to think is modern: strategic foresight, risk management, long-term thinking beyond individual lifetimes. Yet here it is, embedded beneath stone walls laid centuries ago. For an American audience raised on the idea that progress is linear, this is where the tension really sits. Not in whether ancient people were advanced, but in whether our definition of advancement is too narrow. We measure progress by tools, by machines, by visible complexity. But planning depth doesn't always announce itself. Sometimes it hides, quietly doing its job until someone stumbles over it centuries later with a scanner. And that brings the story back to the present moment. Because now that this system has been detected, mapped, and discussed, a new question enters the room. Not an ancient one, a modern one. What do we do with it? In the US, once infrastructure is acknowledged, it becomes regulated, studied, debated. It stops being invisible. But some systems were designed to be invisible for a reason. Interfering with them without understanding their purpose can create the very problems they were meant to prevent. That's why there's hesitation now, not fear, responsibility. Because the ground beneath Cusco has been holding something stable for a very long time. And stability, once disrupted, doesn't always forgive curiosity. Once that question takes hold, it doesn't let you go easily. Because now you're no longer looking at an ancient city. You're looking at a response. And responses don't exist in a vacuum. They exist because something made them necessary. This is where the comparisons got uncomfortable for a lot of people following the data closely. When similar underground patterns were pulled up from other sites, not identical but familiar, the conversation shifted again. Different regions, different materials, same logic. Stone above, controlled emptiness below. Load managed, stress redirected, silence preserved. In the United States, when patterns repeat across unrelated systems, engineers don't call it coincidence. They call it a design principle. And design principles emerge when problems recur. So what kind of problem recurs often enough, across cultures that never met, to justify building what amounts to invisible insurance beneath your most important structures? The easy answer is earthquakes. Cusco sits in a seismic zone. That explanation feels safe. It fits the map, but it doesn't fully hold, because the underground network doesn't mirror seismic reinforcement the way modern systems do. It avoids some fault lines, yes, but it also ignores others that would be considered dangerous today. It's selective in a way that suggests a different priority. Water was the next candidate. Flood control, subsurface drainage. Another reasonable idea. Until hydrological models showed that many of these voids sit above water tables, not within them. They aren't channels guiding water away. They're dry, intentionally dry. Dry spaces beneath stone aren't about floods, they're about stability. Now think about how Americans talk about infrastructure failure. Bridges collapsing, buildings pancaking, systems that fail catastrophically when forces exceed expectations. Modern engineering is obsessed with worst-case scenarios because we've lived through them. Ancient builders didn't leave us manuals, but they left results. And the result under Cusco looks like someone planned for something beyond daily use, beyond weather, beyond ceremony. It looks like contingency. That word doesn't show up in archaeology textbooks very often, but it shows up constantly in American planning meetings. Contingency means you build for something you hope never happens. You hide it, because if it's visible, It changes how people behave. Now here's where things get quiet again. If this underground system was contingency infrastructure, it means the builders expected a force that could affect the entire city, not localized damage, not routine stress, something citywide. And if that's true, then the absence of damage today isn't comforting. It's evidence that whatever they planned for either never came, or came and was handled. Both options are unsettling, because one implies fear without fulfillment, the other implies success without memory. At this stage, skepticism hardened. People pushed back, not against the data but against the implication. This is where American audiences usually disengage, because it feels like the story is drifting toward speculation. But notice something important here. The speculation isn't filling gaps in evidence. It's being forced by the evidence. The data keeps closing doors. It's not ritual, it's not storage, it's not transport, it's not drainage. Each explanation fails for practical reasons, not emotional ones. And when practical explanations fail repeatedly, engineers don't invent myths, they question assumptions. The biggest assumption here is that ancient cities were passive, that they reacted to their environment only on the surface, that deep planning belonged to the modern world. Cusco doesn't agree, and neither do the stones sitting quietly above those voids, stones that have outlasted empires, earthquakes, colonization, and time itself. If you grew up trusting that modern engineering is the peak of human foresight, this should make you uncomfortable, in a very specific way, because it suggests that long before blueprints, before digital models, before concrete and steel, someone was already thinking in terms of system failure and prevention, and they were thinking far enough ahead to hide the solution where no one would question it. That's not primitive thinking. That's cautious thinking. And cautious thinking usually follows experience. That last point is where the weight of it really settles. Cautious thinking doesn't appear out of nowhere. It's learned. It's inherited. It comes from seeing something go wrong and deciding it can't be allowed to happen again. In the US, most of our invisible infrastructure exists because of disasters we still remember. Floods that wiped out towns, fires that erased cities, collapses that forced new codes into existence. But beneath Cusco, there's no record of the disaster that would have justified this level of foresight. That absence is what keeps pulling people back to the data. Because if this underground system was built in response to a known threat, then either that threat predates our written memory, or it was considered so fundamental that it didn't need explanation, like gravity, like weather, like something you plan for without arguing about it. When researchers tried to model what kind of force would require this type of response, they kept running into the same problem. Ordinary stresses don't justify sealed, inaccessible spaces designed to manage load and stability across an entire city footprint. You don't overbuild like this unless underbuilding once cost you everything. This is where comparisons to American cities become uncomfortable again. Imagine discovering that beneath an old East Coast city, something was built after a forgotten catastrophe. No plaques, no stories. Just quiet preparation layered into the ground. You wouldn't call that superstition. You'd call it trauma embedded into design. Cusco's underground network feels like that. Design shaped by memory we no longer have. And here's another detail that doesn't get much attention. The voids don't just support the city. They respect it. They stop short of certain areas, sacred zones, key intersections, as if there were rules about where this system could and could not exist. That implies coordination, not just with engineering constraints, but with social ones. That combination is rare. Even modern projects struggle to balance technical needs with cultural boundaries. Yet this system does it seamlessly. When that realization sinks in, the idea that this was all symbolic collapses completely. Symbols don't negotiate with geology and culture at the same time. This is where the story starts pressing on something deeper than archaeology. If ancient builders were capable of planning for large-scale failure, capable of hiding solutions beneath daily life, and capable of doing it without leaving explanations, then our timeline of when humans began thinking this way might be wrong. Not dramatically wrong, quietly wrong. The kind of wrong that doesn't announce itself until enough small pieces refuse to fit. At this stage, one of the hardest questions finally surfaces, and it's not about Cusco anymore. It's about us. If we stumbled onto something like this beneath an American city today, would we admit what it implies? Or would we downplay it, reframe it, file it away as an anomaly so it doesn't force us to rethink our own sense of progress? Because history isn't just a record of what happened. It's also a record of what we choose to remember. The underground network beneath Cusco doesn't shout. It doesn't demand attention, it just exists. Quiet, finished, patient. And the most unsettling possibility isn't it that it was built for a disaster we done? Do you understand? It's that it works so well, we forgot why it was ever needed in the first place. That's where this discovery leaves us. Not with answers, with a recalibration of what ancient people expected, of what they feared, and of how far ahead they were willing to plan, even if no one would ever thank them for it. And that recalibration doesn't fade once you step away from the scans. It follows you, because it forces a comparison that's hard to escape. Modern cities trust visibility. We trust signs, records, documentation. If something matters, we assume it will announce itself. Permits, blueprints, press conferences. That's how we convince ourselves we're in control. What sits beneath Cusco breaks that assumption completely. Because this system doesn't announce anything. It doesn't advertise intelligence. It doesn't leave instructions. It doesn't even invite interpretation. It simply exists, doing whatever it was designed to do without asking to be understood. That's a very different philosophy of building. In American terms, it's the difference between a public monument and a failsafe. One is meant to be seen. The other is meant to be trusted without being noticed. What's unsettling is how familiar that feels once you name it. Most people in the US live above systems they never think about. Pressure valves, load buffers, emergency channels. Infrastructure designed not for daily life, but for moments when daily life breaks. The only difference is, we know those systems exist. We vote on them. We argue about their budgets. Under Cusco, there was no argument, just execution. And the more researchers tried to isolate this discovery as unique, the harder that became. Similar void management logic shows up beneath other ancient stone complexes scattered across the world, each adapted to local materials, each silent in its own way. Not copies, variations, like a shared language with different accents. That matters, because shared languages usually emerge from shared experience. This is the point where people often expect a dramatic reveal, a single explanation that ties everything together. That expectation itself is a modern habit. Ancient systems didn't work that way. They layered solutions. They planned redundantly. They accepted that not everything needed to be explained to function. So instead of a single answer, what you're left with is a boundary. On one side of it is the idea that ancient cities were reactive, surface level, limited by tools and imagination. On the other side is the uncomfortable possibility that they were proactive, system-minded, and willing to invest enormous effort into problems they never intended to memorialize. The underground network beneath Cusco sits exactly on that boundary. It doesn't prove catastrophe. It doesn't prove advanced technology in the way people usually mean it. What it proves is planning depth, and planning depth is harder to dismiss because it doesn't rely on speculation. It shows up in choices, in what's built, in what's left empty, in what's hidden on purpose. If you replace Cusco with an American city in your mind, the implications sharpen fast. We don't question underground systems once we accept their necessity. We question them when they appear without warning. That's why this discovery feels unsettling rather than exciting. It suggests that long before modern engineering language existed, someone was already thinking in terms we consider modern. Risk, load, failure, prevention. And they were thinking far enough ahead to know that if their system worked, no one would ever notice it. So the most honest conclusion isn't that ancient people knew everything, or that we know nothing. It's simpler and harder to sit with. They were preparing for something they understood well enough to respect but not well enough to control openly. And whatever that was, the quiet stone beneath Cusco suggests it wasn't rare, just familiar enough to plan for. The scans beneath Cusco show a system that exists, that was planned, and that still works in the only way a system like this can work: by staying unnoticed, by doing its job without explanation, by never asking to be understood. There's no evidence of daily use, no signs of panic, no marks of emergency response, which means whatever this network was designed to handle, it wasn't something that happened every year or every generation. It was something rare enough to plan for carefully and serious enough to plan for deeply. That doesn't tell us what the threat was, but it tells us something just as important. The builders didn't need us to remember it. They weren't trying to warn the future. They were trying to protect it. And protection doesn't need an audience. It just needs to work. When you look at it that way, the underground beneath Cusco stops feeling mysterious and starts feeling intentional in a very human way. Someone looked at the world, didn't like the odds, and decided to build something quiet that would outlast them. No myths, no monuments, no explanation carved into stone. Just preparation, and maybe that's the part we struggle with most today. The idea that the smartest thing ancient people did wasn't something they wanted credit for, but something they hoped would never be noticed at all. That's not a lost secret. That's a lesson we forgot how to recognize. And if this kind of discovery makes you stop and rethink what you thought you knew, that's exactly why this channel exists. We're not here to sensationalize history. We're here to look at the parts that don't fit clean explanations. If you want to keep seeing what turns up when modern tools are pointed at ancient places, make sure you're subscribed, not for theories, but for evidence as it appears. Because the ground under old cities is starting to talk again, and it won't do it all at once. And once you reach that realization, the discovery stops feeling distant in time and starts feeling uncomfortably close. Because planning for failure is not a cultural quirk, it's a mindset. And mindsets don't disappear unless the conditions that created them disappear too. In the US, we don't build hurricane shelters in places that have never seen a storm. We don't reinforce bridges unless we've learned what happens when they fail. Preparation is always downstream of experience. That's why the underground system beneath Cusco feels like a memory made of stone, not a story, not a myth, a response. No overbuilding, no sprawling maze for the sake of grandeur. Everything is measured, limited, enough to do the job and no more. That kind of restraint usually comes after trial and error, when builders know exactly what's required and exactly what isn't. Modern American infrastructure looks like that too once it matures. Early systems are messy, later ones are precise. Cusco's underground network doesn't look like an experiment. It looks like a final draft, and that should give anyone pause, because final drafts imply previous versions, attempts that didn't survive, solutions that weren't good enough. Those earlier versions are missing from the archaeological record, which brings us to a quiet but important point. The absence of evidence here isn't neutral. It's selective. We see the solution, but not the failure that led to it. That asymmetry is rare. Usually ruins tell us what went wrong. Here they tell us what went right. That inversion is what keeps drawing comparisons to contingency planning in modern cities. Backup systems don't advertise the disasters they were built for. They exist so those disasters never become stories. If this underground network was built to prevent something, then its success would erase the very evidence we'd need to understand it. And that's a deeply uncomfortable loop, because it means the better the system worked, the less history it left behind. At this stage, the discovery under Cusco stops being a puzzle to solve and starts being a mirror. It reflects a version of human behavior we like to think is modern: strategic foresight, risk management, long-term thinking beyond individual lifetimes. Yet here it is, embedded beneath stone walls laid centuries ago. For an American audience raised on the idea that progress is linear, this is where the tension really sits. Not in whether ancient people were advanced, but in whether our definition of advancement is too narrow. We measure progress by tools, by machines, by visible complexity. But planning depth doesn't always announce itself. Sometimes it hides, quietly doing its job until someone stumbles over it centuries later with a scanner. And that brings the story back to the present moment. Because now that this system has been detected, mapped, and discussed, a new question enters the room. Not an ancient one, a modern one. What do we do with it? In the US, once infrastructure is acknowledged, it becomes regulated, studied, debated. It stops being invisible. But some systems were designed to be invisible for a reason. Interfering with them without understanding their purpose can create the very problems they were meant to prevent. That's why there's hesitation now, not fear, responsibility. Because the ground beneath Cusco has been holding something stable for a very long time. And stability, once disrupted, doesn't always forgive curiosity.